Hello and welcome to another fun video of Rust traits. We're going to be talking about what makes Rust super cool. It's not an object-oriented language, but it is a data-focused language. So what do I mean by that? Well, let's say we're just going to make a number, 5, right? Like that. Cool. This is going to be, just to be very clear, an I32, so a 32-bit integer. Let's say we need to do something with this. So we need to make a vector from this, and the vector is going to be of the size determined by the number, and it's going to have nothing but zeros in it. Well, there's no built-in functions that do that. Vector, to vector of zeros. So there's no built-in functions that do that. We're going to get this and it's going to say, that doesn't have anything like that. It's actually going to say this is a primitive type, so it doesn't have any methods found like that in a I32. Oh no. Well, we could do this. We could actually just make a function to vector of zeros, which takes an I32 and returns a vector of I32. And the way we would do that is we could go, so let's say let's mut b equals vec new, and maybe an I32 turbofish so that we know what type of vector it is. And then we're just going to go let, so we'll get n, for n in, and we're going to do a 0 range like that. Vector push the number 0. Oops, that would be the character 0. So we're going to push 0 as an I32 like that. Great. So if we return it now like this, we've got ourselves a little function. So to vector of zeros I. So let's print this one out, like so. And actually we're going to add this as the debug because it's going to vector. So, and let's see, yep, so that should be all good. So now if we actually run this, cargo run, it's going to build a vector out of those 5. It's going to make, 5 zeros in a vector. Very nice. However, let me show you a little bit of a more interesting way for us to do this, and you'll see why it's more interesting in a second. So, how about, instead of printing it, we just equal the vector equals to vector of zeros I, like so. Then we have a vector, and let's say we also want to make that vector, we want to add 5 to every one of those things. So we can say again, let vector equals add 5 to vector of v, like that. And again, we have to now make this function. So add 5 to vector, like so. We're going to take a v for a vector of I32, and we're going to return a vector of I32. So let's mut new v equals vector, again turbofish it, I32 new, for item in vector, and we're actually going to use the iter, so it generates an iterator, and we're going to new v push I plus 5, like that, and pass back the new vector. Great. So let's see how this goes. What's going on here? Expect structure vector, and that should be fixed. There we go. Just because I didn't save properly. So if we then print the vector now, it should be a vector full of 5s. Let's see what happens. And sure is. Okay, but look at this. We're assigning this value. We're assigning a value again. We're assigning a value again. What a pain in the butt. So let's see, is there a better way we can actually do this? Well, let's go back to look at this for a second. So what we actually need is we need two vector of zeros. We need that to be a trait of the I32. So why don't we make this a trait? We'll call this vectorizer is the trait. And function two vector of zeros, I32 to vector I32, is going to be one of our functions in the trait. Then, if we go to implement, this is so cool, I love this so much. If we go to for I32, we're actually able to implement this function for the type of data. And because, like I was saying before, Rust is a data-driven language. So you want to establish your data, and then you can apply any traits you want to any of the data. So instead of actually making new functions, we're just going to apply these traits to the actual data type itself. So what is this result? So two vector of zeros, I32, very good. So we'll just go two vector of zeros, I32, and then it's a two vector 32. I'm lazy because I had this very nice piece of software that used to just, extension on my computer that would actually just do all this stuff for me, put in all the types, but it's not on this one. Oh well. Anyways, it makes me have to show you guys what I'm actually doing. So vector of zeros, and we're going to just copy and paste this like so. Great. Now it's going to return a vector. There it goes. Everything's fine. So let's get rid of that, because we've added it now as a trait for the I32. So instead of let I, equals 5, we can just skip right to the vector. So we take 5 I32 like that, put in a period, and do two vector of zeros like that. Now, instead of one more thing I forgot. Now we put a reference to self instead of into its own. Let's see. Yes. So instead of its own a new integer, we put in a reference to self. Wow! Look at that. Now print line. We're going to print this vector and take a look at what has resulted. Yep. Say it's a vector. So. Okay, so local variable with name v still exists. V push. Let's see. Okay. My mistake. So for I and self, like that, because there's no I anymore. It's not an integer. Okay, so, and we can also, we don't, because we're not keeping track of that. So there we go. Okay, let's try it again. Cool, and there we go. All we did was take the trait of the I32 and we generated the vector that way. Now you might be saying, is this really any better or valuable? Well, the thing is that in Rust we do a lot of chaining. So chaining is where we would add another function to this. So we wanted to add 5 to vector as well. We can do it like that, and we're going to move this into a new trait. So trait, let's say vectorizer, vector adder, and we're going to do the add function add 5 to vector with, again, a reference to self instead of the vector this time, but returning a different vector of I32. And we're just going to go like this, and all good. So what happens once we, oops, what the heck am I doing? All right, what happens once we implement vector adder for vec I32? So yes, sorry, this one goes in here, and in the trait we're just going to add Actually, you know what? I'm going to show you a different way. If we do that in there, because Rust allows you to have traits that actually have the full function in them. It doesn't just have to be a function that is, yeah, so let's do these. So this is in self.iter, like so. Okay. Is it not found in self? No iter for self. So 5 to vector. All right, let's see. Okay, I fixed it up. Actually, we can't do the implementation in the trait because we are actually need to do it in the implementation. Otherwise, it's not going to know what self is. So anyways, something to keep in mind is if you do have a generalized formula that doesn't involve the actual specific implementation, you can just put it in the trait and it'll work. Now that we've added that to that, you can see, look how simple our formula is. We take an I32, 5, we send it to a vector of zeros, we add 5 to the vector, we print, run. There you go. And let's say we wanted to make this 10, well, easy peasy, a lemon squeezy. And now it'll become a vector of length 10, like so. So imagine doing this for anything you need to. You can do it for any data you need to, any user-defined structures, any primitive data, any types. And it's a different way of thinking, because if you were doing object-oriented programming, you wouldn't be able to add these traits universally. The methods are sort of a part of the object, where in Rust they can be applied to any object as long as the object implements the functions that they implement. So you may have seen things like from. From is commonly used trait that applies to many different objects when you want to create an object from something else. You may have seen new. New is a trait that applies to virtually all objects, which just returns a copy of itself. So a lot of these traits are universally applicable, and when you're making a new program, you're probably going to be starting with some data and converting it. So you take your data, you find out what it is, you apply the traits you need to get to where you want to go, and then you're done. Rust is one of the coolest programming languages I love, but this part is a little bit unusual, so but super powerful. So I hope you enjoyed this video, and if you have any questions, feel free to comment, like, subscribe. Have a good one.